Okay, this will be video 5. This is actually now my third attempt at this one. I keep making silly mistakes. We're actually not going to do number 9 because it's pretty straightforward. So we're going to pick things up on number 10. And so I need to start with my derivative, and we have a product rule. And the derivative of x is 1 times the second e to the 1 over x plus the first times the derivative of the second. So the second one is e to the 1 over x, and so the derivative of e to the 1 over x is e to the 1 over x times the derivative of 1 over x. Of course, 1 over x is x to the negative 1, and the derivative of that would be negative 1 x to the negative 2, or negative 1 over x squared. So we have negative 1 over x squared. Alright, we need to clean this up before we move on. So I have 1 times e to the 1 over x plus this times this times this, which is negative, so it becomes minus x on top, x squared on the bottom. So I end up getting e to the 1 over x over x. And that's not bad, but I'm going to take one additional step, and I'm going to turn it into a quotient. So I need a common denominator. So I need to multiply this by x over x, which gives me a derivative of x, oops, wrong color, 1 over x minus e to the 1 over x all over x. And I'm going to take one more step, and I'm going to factor out an e to the 1 over x, leaving me with x minus 1 over x. So there's my first derivative that I'll use for my first derivative test. But I also need the second derivative, so let's change colors. And now let's think about the second derivative. And there's just no pretty way around it, so I'm just going to have to do the math here and be unhappy. It is 12:30 in the morning if anybody cares on a Monday night. I'm just looking for a little sympathy here. Alright. So I'm just trying to decide which one to use to take the derivative, and I don't know. It doesn't really matter. It's gonna suck no matter what you do. So let's just do it of the boxed answer here. So I got to do a quotient rule, but involved with that is a product rule on top. So the derivative of the top, e to the 1 over x, is e to the 1 over x times, and again from before, the derivative of 1 over x becomes negative 1 over x squared. Okay, so that's the derivative of the first term times the second term. Oh, this is not friendly. Plus the first term times the derivative of the second term, which is just 1. Okay, so everything we have up here is the derivative of the top. But now we need to take that and multiply it by the bottom minus the top times the derivative of the bottom, which is 1, over the entire thing, well, under the entire thing, squared. Okay, clearly we have some cleaning up to do. So my second derivative equals, let's see, I have a negative e to the 1 over x squared times x minus 1 plus an e to the x. All of this times x minus, I'm going to distribute that. I get x e to the 1 over x plus e to the 1 over x. Again, all of this is over x squared. And now I need to distribute this x into the problem. So, x times the first term here, it's going to cancel out one of those x's. So that x and that are canceled. On top, I could distribute. So I get negative e to the 1 over x times x plus e to the 1 over x. Okay, so let's check this. I've distributed the x here, canceled, distribute. So I also have to multiply here, so I get plus x e to the x minus x, hold on, this should be 1 over x. Okay, minus x e to the 1 over x plus e to the 1 over x. So what do we have? We have a mess is what we have. Cancels, cancels. So now we're left with, again, all of this is over x squared, so I left that off. So now I'm down to wishing this problem didn't exist. Okay. So, I have this term divided by x. I have this term divided by x plus this term. And all of this is divided by x squared, or dividing by x squared is the same as multiplying by 1 over x squared. So what that means is I'm multiplying all of these guys by 1 over x squared, which is going to turn this x into x cubed x squared. So I need a common denominator to be able to add all these together. So this guy needs an x over x, which brings me to something that actually turns out fairly friendly. Negative x e to the 1 over x cubed plus e to the 1 over x cubed plus x e to the 1 over x cubed, and I get my first break of the day, and that this term and that term cancel, leaving me with a second derivative of e to the 1 over x cubed. Alright. That was awful, and none of it was calculus. That was all simplification. It was all algebra. Okay. So now I have the two pieces I need. And I have no room. So I'm going to do some erasing. Okay, first derivative test. So I need to set the derivative equal to 0. And undefined. So when is my derivative equal to 0? When is my derivative undefined? Focusing on the numerator, because that's the only way a fraction can equal 0. I see very easily that e to the 1 over x is always positive. So the only time is at x equals 1. And when is the derivative undefined? That would be when x equals 0. Because I can't divide by 0, I can't divide by 0. Which brings up the first thing I should have done, which is I should consider the domain of the function that I've been given. And the function has a 1 over x here, so 0 is actually not even part of the function. Which makes sense why I then got an undefined derivative, because if you don't have a value, you can't have a derivative. Alright, so I have two values that I need to put on my sign chart. Alright, so we got to do that. And my sign chart would then look like 0 and 1. I can barely see my derivative here at the top of the screen. So, the derivative, plug in a billion, and I get e to the 1 over a billion. E to anything is always positive. So I have a positive times a positive over a positive, which is positive. 0 to 1, I put in a half. E to the, it doesn't matter, it's positive. Half minus 1 is actually a negative. Over a positive, I get a negative. Plug in negative a billion, I get a positive. Times negative a billion minus 1 is a negative over a negative, which is a positive. So now I know I'm increasing, I'm decreasing, I'm increasing. Alright, first derivative test. Okay, second derivative test. My second derivative is equal to 0 when the numerator is 0. E to the power is never 0, so I get none. And I got to figure out when my second derivative is undefined. And again, I can't divide by 0, so that would be x equals 0. Knowing, again, that that is not an inflection point, but it is simply undefined because the derivative was undefined. And so when I took the derivative of the derivative, I'm still undefined. Okay, so then that makes my sign chart for the second derivative. I'm still going to put the 0 on here. And so when I plug in a number bigger than 0 to my second derivative, I get a positive and I get a negative. So that tells me then all of my answers. What am I increasing? Negative infinity to 0, 1 to infinity. Decreasing, 0 to 1. Local maximum, not at 0, because I'm undefined at 0. There is no value at 0. Local minimum at 1. Concave up, 0 to infinity. Concave down, negative infinity to 0. I have no inflection points, because although I do change concavity at 0, it isn't a point, it's something else. So that gives me all of my answers. And I will now stop this video. And we'll pick up the rest of the problems in another video still to be made.